Welcome to the Health Workforce Technical Assistance Center's webinar series. This webinar is entitled ArcGIS, an Introduction, and it was presented by Nafin Harun and Robert Martiniano on July 25th, 2017. Hello, my name is David Armstrong, and I'm the Director of the Health Workforce Technical Assistance Center. And today's presentation is an introduction to using ArcGIS. And our presenters are Nafin Harun and Robert Martiniano, both from the Center for Health Workforce Studies located at the University of Albany here in New York. Now, during today's event, you may ask questions either by raising your hand, at which time we will unmute your phone, or by using the chat panel on the right of the screen. Also, when today's event ends, you will be directed to a short evaluation survey. So please provide us with your feedback. We'd greatly appreciate it. Now, at this point in time, I'm going to go ahead and turn our event over to our presenters. Robert, I believe you're up first.
Yes, good afternoon. Hello, everybody. I know a number of you I've met at the PCO meetings. So today we want to do a couple of things. I want to start by giving you an overview of kind of geography and data just to give you some background. And then Nafin is going to go into kind of the nuts and bolts of building maps using ArcGIS. So a couple of things on some paperwork issues. At several times throughout the presentation, we're actually going to pause and let you ask some questions. Additionally, if you need clarification on either concepts or steps, please use the chat box to indicate that you have a clarifying question. You know, we here use mapping for a number of issues. One, we use it to supplement what we do with our HWTAC analysis, but we've also used it for identifying rational service areas. We've also used it for doing our community needs assessment. So there are a number of things you can use it in your jobs in the primary care offices to help you both understand where the workforce is, understand where services are, and display that for those in your government and other stakeholders. So I want to start with, again, just giving a brief overview of using data and levels of geography, because I think that's important as context for when Nafin starts describing what to do. So much like SAS or SPSS or Excel, GIS is a tool, and it's a tool in some ways a little more powerful than other tools in terms of mapping, and obviously a little less powerful in terms of a tool in terms of SPSS or SAS or Excel, but it can still do both. It can help you analyze data and also display data. For example, you could do some basic counts of how many physicians are in a county or in a service area, but you could also be a little more sophisticated and start looking at things like how many physicians per capita or how many physicians per hospital. But again, you can go as far or as close as you want in terms of understanding how to use the data, or in depth or not in depth. I wanted to talk a little about levels of geography because I think that's important as you do mapping. And in times there are levels of geography that can be too large. So for example, if you're looking at access to care, you probably don't want to do it at a state level, because we know that obviously, especially in larger states, access to care is going to be much smaller than at a state level. Similarly, and for us as PCOs and working with PCOs, that things like fluoridation you really don't want to do at a small level like at a block group, because we know fluoridation generally is at a much larger level than that. So a trick or an issue with mapping is at what geographic level do you really want to do your analysis? And it's not an easy thing to decide. You just kind of have to feel your way through it and figure out what's the best way to do it. Ultimately, unfortunately, sometimes the data that's available is going to define what level of geography you use. For example, in New York, most of our healthcare data that's reported by the New York State Department of Health is at a county level, so therefore most of our analysis is at county level unless we can get some record level information from Medicaid or other things. And some of your states that have health district areas or health districts, it may be that's how they report data. So you may have either a smaller or a larger geography to report on. There are a number of different data sources that you can use in this, and Nafin's actually going to pull in one and kind of explain how to use it. But you can use demographic data. We've used American Community Survey data, and we've used other data just to explain percent poverty to percent of individuals under 65 or over 65. We've looked at the percent of the population who are racial or ethnic minorities. Again, as a way to start explaining things like hospitalizations, avoidable hospitalizations, maybe other issues. Also, we have healthcare indicators we can report on, such as I've just explained, avoidable hospitalizations, regular hospitalizations, percentage of the population with diabetes, or incidents such as cancer, flu, or things like that. Finally, the healthcare infrastructure, which is what most of us actually work on more, which is where are people or where are beds. So you can pull information on the number of beds per county, the number of beds per health district. You can indicate where a hospital may be by a point, or you can indicate specific physician offices where they may be by point. So again, I just want to give kind of a brief overview, and I want to kind of put this into context. Before Nafin starts, do we have any specific questions? Okay. Nafin, it's up to you.
Thank you, Robert. So before we start the demonstration, I would like to cover a few basic concepts that are important to understand. First, I would like to talk about data models. So in general, we have two types of data models, vector model and raster model. Vector models are representation of features that can be displayed on the map. A feature can be a point, a line, or a polygon. A point can represent a specific location, like a hospital. A line can be a section of a road, and the polygon is basically an area, like a county.
So just to note, raster models are basically images or pictures. So in this case, you're seeing the southern tip of Manhattan, but there are other raster models that could be topology, or mountains, valleys, things like that. I've seen other ones based on temperature. So again, you're bringing in an image that you're going to be overlaying something else on. But, you know, just as an important note, raster models can't be edited.
Yes. So as Robert said, raster models are basically images, and they do not contain any features. And today we will work with vector data mostly that represents points, lines, and polygons. So let's continue and talk in more details about features and feature classes. So as I said, features can be points, lines, or polygons. And a group or a collection of the same type of features, for example, several points, will be called feature class. So by definition, a feature class is a collection of features with the same geographical representation. A feature class can be saved in one of two common formats, shapefile format or GeoDatabase feature class format. Shapefile is an old format consisted of several files in a regular folder. And a GeoDatabase feature class is a newer version of data format stored inside a GeoDatabase file. So what is a GeoDatabase file?
These two maps that you're seeing, the one on the left are basically, again, a point feature class, and what that shows is where physicians are located. It could be hospitals, it could be federally qualified health centers, it could be anything that you could put points on. The one on the right is polygon. It could be census tracts, it could be counties, it could be, again, if you're in a state that has health districts, it could be health district. It's an aggregation of things, and as you can see, the boundary lines indicate where the separation is between one part of the polygon and another.
So, as I said, A feature class is a group of features with the same representation, same geometry, and they can be stored in a GeoDatabase file. So GeoDatabase file is a storage file. It can store several feature classes, for example, a polygon feature class that represents states, a point feature class that represents major cities. Also, it can store tables that contain attribute data which can be linked to other feature classes. For example, demographic data per state or geographic attributes of the state. It can also store other files that are used for relationships between the feature classes. So these are the basic concepts that I wanted to cover before using the software. So now let's go over ArcGIS core applications.
Are there any questions before we proceed? Yeah, just to emphasize, the database really is bringing in a number of different files you're going to use to build your maps. And again, they can be points, hospitals, physicians, whatever, polygons, counties, cities, census tracts, and a line you could bring in roads if you wanted to try to understand how patients may go for services and whatnot. And the other thing that I want to emphasize is attributes, and Nafin went over this a little. That attributes are really the data elements within a table or within a file. And they could be things like counts, population counts, physician counts. They can also be latitude and longitude if you're a point. They can be square miles if you're talking about polygons or boundary files. And then finally, also, many of them, or they all should, have had some identifiers, and we'll talk about this a little later. They could have your state abbreviation. They could have a state code or a county code. And that's going to be important as you combine data to make sure that you've got something there that uniquely identifies the record within a file, so that if you have to combine it or you have to display it, you're able to do so.
So ArcGIS includes two core applications, ArcCatalog and ArcMap. ArcCatalog is mainly for data management, where you can create geodatabase files, import tables, and move files. Once we will start the demonstration, in ArcCatalog we will create a geodatabase file and import 3 shapefiles into it, and import a table that contains physician and population data that was downloaded from the HRSA website. ArcMap is the main application for spatial analysis and map development. After we organize the data in ArcCatalog, we will build a simple map in ArcMap and review different ways to display our data. So once you install ArcGIS, you should have these two applications on your computer. So let's start with the demonstration in ArcCatalog. You should see on the left side of the screen the catalog tree, which shows the folders in your computer that are connected to ArcCatalog. So the first thing that we need to do is to connect a folder to ArcCatalog. To do this, click on the Connect to Folder and select the folder that contains the data and click OK. Once you have access to the folder, you can see the files by clicking on them. In this case, we have 3 shapefiles: cities, major roads, and U.S. states. In the content panel, you can see the name of the file and the type of the file. Usually, shapefiles have SHP file extension. In the preview panel, you can see how it looks on the map. On the bottom of the screen, you have the preview selection, and you can select the table. This will show you all the attribute data linked specifically to this feature class. You can see that you have unique IDs, shape type, names, and land and water coverage. In the description panel, you can see all the information that the supplier provided for this specific feature class. It is recommended to keep all files organized in one geodatabase file. So let's create one. To do this, right-click on the folder which will contain the geodatabase file, New, File Geodatabase, and name it. Now let's import the files into the geodatabase. To do this, right-click on the GeoDatabase file, import feature class multiple. This will allow us to import several shapefiles into the GeoDatabase file.
So essentially what we're doing here is the database is really a collection of different shapefiles as well as tables, and you're pulling it all into one place versus having it in multiple places on your computer. Again, as you think about our catalog, what you're really showing is your directory of your computer. So if you want to kind of put it in older terms.
So in the new folder, click on the input feature and locate your shapefiles. Select them and add them one by one. And click OK. Now you can see that it's in progress because there's a sign that this specific tool is working, and we have notification that the import was successful. Now we will import a table named AHRF 2016 that contains the attribute data of population physicians and their ratios. You can import Excel files or any other comma-separated value files into the GeoDatabase file. So to do this, right-click, import, table, locate the table, and name it. Make sure that you don't have spaces for the names, and the field names don't contain any special characters, start with numbers, or have spaces in them. Otherwise, you will get an error. And click OK.
So, Nafin, a quick question to explain to the audience. What is the benefit of bringing them into one place, into your GeoDatabase? So, the benefit is that you have an interface that allows you to manage the data better. That interface is basically our catalog. You can do all the functions here. You can delete, you can rename, you can import, export, and move files between or within GeoDatabases. Because usually, spatial files they contain several files in them. So if you have, for example, a shapefile, this is how it will look inside the folder. You have several files. So if you want to rename it, it will be pretty complicated. So having everything here just makes it easy. It's a good way to, I assume then it's a good way to manage your files for if you're doing a map or a group of maps.
So now that we have all the files that we're going to use in one GeoDatabase file, we can move to ArcMap and work with the data.
Let's stop right here and ask if anybody has any questions. So essentially the first part is really just managing your files and pulling them all into one place to give yourself the ability to build one or more maps from the same data.
So let's open ArcMap. As I mentioned before, ArcMap is the primary mapping component of ArcGIS, and it is designed for map development and spatial analysis. ArcMap displays map contents in one of two views, data view and layout view. You can switch the view on the bottom of the screen and select the view in which you want to work in. So whatever and also you can see it in the view panel here, and you can select it here. In the data view, you assemble the layers and the data that compose the map. In the layout view, you design the map and add elements to it. Whatever you see in the data view, you will see in the layout view. On the left side of the screen, you can see the table of contents, which will display all the layers that compose the map. On the top, you will see the toolbars, which you can customize and move around. Let's add, for example, a specific tool. Click Customize, Toolbars, and you have many tools. Let's add, for example, editor and lock it in the toolbar. This specific tool will allow you to edit the features class content. You can also see Arc catalog within ArcMap just by simply clicking on the Arc catalog, and you will have Arc catalog on the right side of the screen. All the functions and everything that you can do in Arc catalog, you can do here. So you don't need to open Arc catalog in order to manage your files. Let's add the features classes that we stored in the GeoDatabase file and see how it looks on the map. You have two ways to import files into ArcMap. One will be click File, Add Data, and you have a shortcut on the toolbar right here. This is useful when you have multiple feature classes that you want to import at once. You just select them all and add them all together. The second way to do it is just by simply dragging it from the Arc catalog to your table of contents. So let's open the GeoDatabase file that contains all the data and drag them one by one. The order of the layers listed in the table of contents determines how the layers will be displayed on the map. The layer that is on the top of the list will be displayed over those listed below them. Therefore, polygon layers should be on the bottom and point layers should be on the top. You can reorder the layers by clicking the draw listing, and you can drag a specific layer to the top. For example, we put the polygon layer on the top, and as you can see, it blocks all the other layers. So that's why they should be on the bottom. You can also turn off specific layers. If your data consists only one feature class with very few features in it, like, for example, few points, and that's the only feature class that you have, your map will look pretty empty. So you need to add some visual context to your map. You can do this by adding a base map. A base map is a raster data, meaning that it's an image. It's like a background. And it's also available in ArcGIS, so you don't need to download it. To add a base map, you just click the Add Data, Add Base Map. You have several options here. Let's select Imagery, for example, and click Add.
And as you can see, what happened when he added the base map, the dots that were there were more difficult to see because they blended in. So you went in and edited the dots to make them a little larger so they would jump out. You could do it by editing the size, the color.
Yep, so let's remove the base map because for our purposes, we want to show several layers. Now let's review the layers attribute data. To do this, right-click on the specific layer which you would like to review, open attribute table, and this is the exact table that we saw in our catalog with the basic attributes. You can click the table options and select a specific feature or specific group of features by attribute, add fields, or export the table into a computer like an Excel file, for example. You can also select a specific feature by clicking on a specific row, for example, Arizona, and zoom in to the selected feature. This will automatically zoom into the area that has been selected, and as you can see, Arizona is highlighted. you can clear your selection by using the Clear Selected Feature tool, or select the feature by using the Selected Feature tool. You just click on the actual feature. Now California is highlighted, and we can see it in the attribute table that California is selected. If you want to see the attribute data of a specific feature, you can use the Identify tool and click on the feature. For example, we can see all the attribute information of Nevada. Now that we're familiar with the user interface of ArcMap, let's go ahead and build a simple map. So the first step will be joining the demo data to the US state layer.
We have a question.
Okay.
So one of the things that Nafin did was center on the contiguous 48 states. There are ways, and actually we're going to show you at the end of the presentation how to move Alaska and Hawaii into the map as insets. Because we've all had that problem, well, those of us who have done maps have that problem, that it becomes very difficult to display the entire United States when we have Hawaii out to the west and Alaska to northwest. Also, similarly, in some of our states we do that. I know in New York, we will break out New York City and Long Island usually as an inset because it is, they're dwarfed by the rest of the state. So again, that's a great question. We're going to show you how to do an inset at the end, or an insert. Insert or inset?
Inset map.
Inset. We'll show you how to do an inset at the end to be able to move Alaska and Hawaii into what you're seeing.
So as I said, the first thing that we need to do is to join the data that we have in the demo data here to the US state layer. So to do this, first we need to import the data, and we can drag the table exactly that we did with the other layers. Now we have the data in ArcMap.
And just to refresh, an attribute can be a population, can be longitude or latitude if you're a point. It can be square miles if you're looking at, in this case, both land and water square miles. It can be counts of providers, counts of hospitals, counts of hospital beds. And again, it can also be identifying information. In this case, you've got an abbreviation for the states as well as the full name, as well as the FIPS code, which in the United States is a unique identifier for each state. So one of the questions is, can we also show us how to isolate just one state? Isolate in terms of building a map around one state, is that your question? Okay, yes. Why don't we do that at the end? We'll actually show you how to, and we've done it here where we will isolate, bring out a region or a county and try to just focus on that in terms of trying to discuss what's going on in that area.
So as Robert mentioned, FIP state is pretty unique per each state, so we can use this field as the common field to join the two data sets. So to join, right-click on the layer that you want to join to, join and relates, join, and here you have two options. Join attributes from a table, which is basically what we are doing right now, and join data from another layer based on spatial location. This is basically join of two layers based on spatial location. Let's select the first option and select the FIPS code, which is unique for the US states, and automatically it will identify the same type of fields that the demo data has, which is numerical fields, and select the FIPS states. Let's keep all records and click OK.
Quick question for you. I've never asked you this, but what to do for leading zeros, right? I know that, like, if you're trying to link zip codes in New Jersey, Connecticut, whatnot, where there's leading zeros, if some have leading zeros and some don't, what happens?
The join won't be successful. You need to make sure that it's exactly the same type of field. Okay. So numerical to numerical, text to text. So to see that the join was successful, right-click on the layer, open attributes, And you can see that this layer now has all these new attributes linked to it. But it's important to understand that this join is on the fly, meaning that it's only temporary. So if you close the software and open it again and import this specific layer, you would lose the join. So to save it, we need to export it. To export the layer, right-click on it, Data, Export Data, and select the GeoDatabase file that we created. Now, let's create a thematic map that displays the ratios between population and physicians per state. To build the thematic map, right-click on the layer that you want to examine and click Properties.
So why don't you briefly describe what a thematic map is?
Thematic map is basically, if you want to visualize a specific field in your data set, for example, in our case, it will be the population-physician ratio. So we want to visualize this data. So you have several ways to do this. So let's just do like one way, which will be like coloring the polygons. So right-click, Properties, and select the Symbology tab, Quantities, and here you have all the options. So you have graduated colors, and you can see the example here, graduated symbols, proportional symbols, and dot density. Let's select the graduated colors. And in the value field, select the population-physician ratio. By default, you have 5 classes or 5 ranges. So if we want to change the method of classification, click Classify, and here we can select the ranges. You can do manual and type your range here. Let's select quantiles and click OK. We can also edit the number format by clicking the label, Format Label. Let's reduce it to 1 and click OK. Now it's more clean. We can also change the colors and select something. Well, we can stay with the blue since other colors are a little bit more difficult to see.
And when you think about your map and you think about colors, it's very important. So for people who are colorblind, they can be difficult to see. And so you have to think about that. Additionally, if you think people are going to be printing this out in black and white, they may not have access to color printers. You want to think about that, whether you want more distinct colors, or while we're only using colors here, you can also do some kind of cross-hatching that, again, gives you the same kind of distinction. But again, if it's printed out in black and white, you'll be able to see it versus if it's in color.
If you're not happy with one of the colors, you can just double-click on it and select the color that you want. And even go further than this and change the actual values of the specific color and click OK. We can see the thematic map, and at this point we can add labels to our map. So go to Labels tab and check mark the label feature in this class and select the field that contains the labels. In our case, that will be the STUSPS, and we can edit the style. So let's make it bold, and let's go to the placement properties. You can select how you're going to see the labels. So you have several options here. Let's select always horizontal and remove duplicates. Basically, remove duplicates meaning that if you have a state that has 2 polygons, you will see the label twice. So this basically eliminates that. click OK, and we can see the labels. All right.
And this is another case where you need to be careful about colors, because as you can see with Nevada and Idaho and the Dakotas, because it's a darker color, it's a little more difficult to see the labels. So again, I mean, this is a case where you're going to be playing with the colors of the map and the style and color of the labels until you get something that makes sense for you.
We can correct it in the, like after we will design the map. So we can switch to the layout view to add map elements, design it, and solve some of the problems that we see here. So let's switch to the layout view. First, we need to set up the page layout. So to do this, click File, Page and Print Setup, and in the orientation, select Landscape and click OK. Now we can adjust the frame and fit our map in the page. As I said, what you see in the data frame, you will see in the layout view. So if you zoom in, this is what you will see in the layout view. You can also move the map within the frame. As Robert mentioned, it's pretty difficult to see certain labels that has darker background. To fix this, we need to edit specific or individual labels. To do this, right-click on the layer, convert labels to annotations, and this is basically converting all the labels into images, small images. You can select in the map. If you do in the database, it will create a file that will be saved in the GeoDatabase file that you can use later for other projects. But let's do in the map for now and convert. You can close this little window, and now each label is editable. So let's select all these labels by holding the Control key. Right-click, Properties, and change the symbol and change the color to white. Click OK. Now it's visible. Let's add a legend. To do this, click Insert, Legend, and here you can see all the layers that will be included in the legend. In this case, we have only one layer. Click Next, and let's go with the default style. Now, if you want to change some of the titles, you can directly change it in the table of contents by editing the text. And the legend will be updated automatically. If you want to remove some of the elements within the legend, you need to convert it into image. Right now, it's linked to the actual data, but we can convert it into an image exactly like we did with the labels. To do this, you right-click on it and convert to graphics. And you right-click on it again and ungroup. Now you have each element separated, and you can control or edit each one of them. So if we don't want the legend title, we can delete it. We also can edit specific or individual element by right-click on it, Properties, and click OK. I don't like that. Okay. Now we can add other map elements such as north arrow. To do this, you go again to Insert, North Arrow, and you can add the specific north arrow that you want and move it around. You can also add a title to the map. Click Insert, Title, and you can edit it by right-click on it, Properties. Now, if we are happy with our map, we can export it. To export the map, click File, Export Map, and select the format that you want and save it. And we can see the map right here. The map that we've created is a graduated color thematic map, but you can also use other visualizations to display your data. For example, let's examine other type of thematic maps. Make sure that we turn them, all the other layers off. So for example, we have the graduated symbol map that shows the population to physician ratio by the size of the symbol. Another type of map will be dot density that shows the distribution of physician. This is not ratio, it's just like the total physicians per state. And it's it is important to remember that each dot is not indication of the location, it's just a density. So each dot represents about like 200 physicians. And you have another, you can change the representation of the dots. For example, one dot in this map represents 100 physicians. So you can see that it's a little bit more dense. Another essential component in ArcMap is the Arc Toolbox. Arc Toolbox is where you can find, manage, and execute geoprocessing tools. You can find on the toolbar, and here you have all the tools that ArcMap has. For example, if we select a specific tool like Clip, double-click on it, and here you can see all the actions that it does, like how it, you can see how it works and what it does, basically. Every field has its own description. And it's the same thing with other tools that are more sophisticated. For example, spatial statistics tools. So let's do autocorrelation, spatial autocorrelation. You can see that you have the description of this analysis, and it's more, as I said, it's more advanced tools that you can use. So I think we can take some questions before we...
So as Nafin showed you, there were a number of different ways to do the maps, and in this case, the dot density map really is showing you counts, but when we saw the thematic map, it actually started showing you relationships. So where is your state compared to another state in terms of provider or population to provider ratio? Are there any questions? And then we've got a couple of things. We're going to show you both how to do insets as well as how to isolate a state.
So to isolate a state, it's pretty simple. You right-click on your layer, open the attribute data. Let's say we want to isolate Georgia. You select on it, you select that feature, and then while it's selected, you export the map. So right-click, data, export data. You can see here that the selected feature is selected and not all the features, meaning that only Georgia will be exported. And let's go to the demo GeoDatabase file. And now let's turn off the other layers so we can see. Now you have the Georgia only on your map. But it's important to remember that once you map or create maps in a large scale, meaning that you focus on a small area, you need to select the projection. In this case, if you want to see the projection that you work with, you can right-click on the data frame, which will be the will-named layers here. Right-click, properties, and you can see the details of the projection that you're working with. If you want to change the projection, click Properties and select Projection. Now, it's another topic, pretty complicated topic that we can talk about, but I don't think we have enough time. You have geographic coordinate systems and projected coordinate systems. Let's do geographic coordinate systems. Select North America and see how. Now we get a warning because the data is basically has different projection. So it gives us a warning. And this is basically how you isolate a certain state, and you can do all the functions that we did with the entire state, the entire United States. But if you have one state, obviously you can import other feature classes such as county for that specific state. And that's pretty much it.
And let's say within your state you have your state broken out by regions and you wanted to take 6 or 7 counties. You could, as Nafin showed you before, you click on it and then you do control click, and you could do 7 or 8 and create your projection so that it gives you, again, a group of counties or a group of states. So any questions up to this point? And we're still going to do the inset.
For example, this is one state with New York State with the HIPSAs on top of the actual state. So very quickly to do inset map, you need to create another data frame, meaning that you click on the Insert Data Frame, and now you have a new data frame. Let's remove all the other layers so we won't have lots of distraction. You need to make sure that when you're working with a data frame, you need to make sure that the data frame is selected. So if you want to work with the layers data frame, which is just a name, you need to right-click on it and click Activate. Now you will see all the layers that are in this data frame, and we changed the projection, so that's why it's kind of stretched. So let's change it back. Okay, so basically you can copy the layer and paste it in the new data frame. And now in this new data frame, you can focus on the other elements that you want to add. And in the layout view, you can see 2 data frames. One that shows the entire United States, and the second is the Alaska one. But again, you need to make sure that you're working with the right data frame. So for example, if I want to move the first map, I need to select the data frame, and then I can move it around. And if I want to move Alaska or adjust the frame, clear the selection. You can edit this specific frame by select it, right-click Properties, and select the Frame tab and get rid of the frame, so you won't see any frames. Now it looks more neat and clean.
And essentially what Nafin is doing right now is kind of putting it up so that, again, if you're putting it in a report, you're putting it out for a presentation, you've got the ability to move things around, move the legend and the inset around, as well as the main map to get it where you want it, that shows what you want to do. So again, pull in Hawaii, pull in Alaska, then gives you the ability to move things around.
Any other questions?
So what we've done, again, and this is, unfortunately for something like this, I think it's very hard in an hour to kind of get everything you need. But what I would suggest, and I'll open up for questions in a second, but what I would suggest is, now that you've kind of seen this, and again, we are going to record this and put it back online in a couple weeks so that you can go back to it. But what I would do now is go into ArcGIS, kind of play with it, and then as you have questions, I guess, then you can go back to the webinar and see how it was explained. And also, Nafin and I are around, mostly Nafin are around if you have specific questions we can help you with.
One thing is very important to remember is when your map is ready, you can save the actual project by click File, Save As, and an ArcMap project will be saved with MXD file extension. So once you save it, you can reopen it and keep working on your project.
So we have a question. So the question is, are there any features of ArcGIS that you don't like? Personally, I've never used it. I'm a map info person, so I'm going to let Nafin handle that one.
I cannot think of, there are lots of tools. There's many tools, and you can work with their interface and also in the background using Python. That actually makes it a little bit complicated for the intermediate or beginners like users. So that will be something that the software has, it can be advantage or it can be disadvantage. Depends what are the levels of the skills that you have.
Now, do you necessarily need, another question, do you necessarily need ArcCatalog to pull a file in to use it in ArcMap?
You have to have ArcCatalog installed on your computer in order to open the ArcCatalog in either just by opening it in ArcCatalog or to have the shortcut in ArcMap. But you can also work with shapefiles directly and not import.
I have to import them into the
exactly.
database. Okay.
So you can technically you can work with shapefiles without managing it in ArcCatalog.
Another thing is, can you export a shapefile?
Yeah, so basically it's pretty simple. So the way that so if you want to export, you just right-click Data, Export Data, and you select the, instead of going to the GeoDatabase file, go one folder back, and you can change the format. So you have File and Personal GeoDatabase feature classes, which will be the feature classes that we worked with so far. But if you want to export as a shapefile, you just click Shapefile. But as I showed you before, shapefiles are a bunch of files, so they need to be inside the folder. So we can throw it in here. Call it and save. And click, and now we have a shape file that is inside a regular folder and not in a GeoDatabase.
So when you pulled out Georgia, let's say, so you could actually export Georgia now as a standalone shape file?
Yes.
Okay. Can the map, another question, can the map be copied and pasted into Word?
Yes. So when you export the map, you can select the format that you want to save it in. So, for example, we saved a JPEG. This is a JPEG format, which you can drag into Word file like any other image. You can also save it as, or export it as a PDF file. And you have all these files, and most of them can be imported into Word file.
So again, what I would suggest is go back to your desk, and when you have a moment, which most PCOs don't, play with it, and then in a couple of weeks when we have this presentation back online, you can go on and actually check it again against what you've been teaching yourselves. Again, we are available for specific questions if we can help you. Nafin, anything further?
If you have questions, I mean, so there was a presentation for cartography and map design that Katie delivered. That can be also helpful when you design a map. I recommend to go over that presentation, and it will give you some background on how to design a map.
So again, if you have any specific questions, you can reach out to us. I know my email is on the HRSA website and probably in some of the stuff that gets handed out to you guys on a regular basis. With that, we will close. Anything, David?
No, the only thing I have to say is thank you, Robert. Thank you, Nafin. I thought you did a very good job. There's a lot to pack in for just a 1-hour presentation, but I thought y'all handled it very well.
Thank you.
And of course, as always, I thank you and the audience for attending our event today. And as Robert mentioned, a video of a recording of this event will be on our website within a couple of weeks. And I believe Nafin mentioned Katie's webinar she did. It's been a while back, but a recording of that event is also on our website at healthworkforceta.org. And Nafin, did you have one more thing?
Yes, we also provided in the PowerPoint the links that can be useful if you have questions, like basically for every section of this demonstration has its own links, so you can see in the map production, joint spatial or non-spatial data, you have sources and all the topics that we covered. You can find more information in those links.
Thank you, Nafin.
Yep.
And once more, thank you in the audience. I hope you have a good afternoon.